Hi everyone. So today we're going to be talking about how to name polynomials. This whole lesson is about polynomials, and polynomials is just a fancy way of saying it's a big chunk of numbers and letters together. So the first thing we're going to learn is how to name them, and the way that we name them is with two different things. We name them by degree and by number of terms. So the degree is the highest exponent that you see. And the number of terms is how many chunks there are. And when I talk about chunks or terms, the terms are separated by a plus or a minus sign. And so we don't count, for example, if I had like 10x to the fifth, this is considered one term. But if I had 10x to the fifth plus 7, the 10x to the fifth is one term and the 7 is one term, and so that would be considered two terms. So like I said, we're going to name these polynomials by the degree and the number of terms. So we're going to have, each time we name them, or for each example we're going to do today, we're going to have two answers. And so let's get started. So the first example, let me backtrack and say this. So we're going to use these two tables to decide them, the degree and the number of terms. And then depending on what the degree is, you have a specific name for it. And then depending on what the number of terms is, you have a specific name for it. I've given you these in a key terms in your course, so you don't need to write these down or take a screenshot or anything. You should already have them. But let's just go through them really fast. So if you have a degree of 0, which means that there are no x's, that would be considered what's called a constant. If they're a degree of 1, which means that there's one x. There's no exponent, but there is an x somewhere. That's considered linear. If the degree is 2, which means you have an x squared somewhere, it's called quadratic. If you have a degree of 3, which means you have an x cubed, that's your highest exponent is x cubed, it's considered cubic. If your highest degree is 4, or the 4 is the highest exponent, it's quartic, and then 5 is quintic, and then anything that's 6 or above is just called to the nth degree. So if it was the 6th, if 6 was your highest exponent, then it would be to the 6th degree. If 10 was your highest exponent, it would be to the 10th degree. If 100 was your highest exponent, it would be to the 100th degree. Now we're going to talk about number of terms. So if we have only one term, then it's considered a monomial. If we have 2 terms, then it's considered a binomial. If it's 3 terms, it's a trinomial. And then if it's 4 or more terms, and it doesn't matter how many terms it is, it's just a polynomial. So I could have 4 terms, it's considered a polynomial. I could have 1,000 terms, and it's considered a polynomial. Okay, so now let's start going through the examples. The first example is 4x squared plus 10x minus 5. So the first thing I like to do is look at the degree. So the degree, remember, is the highest exponent that I have. So this one has an exponent of 2. This guy has an exponent of 1 because there's only one x. Now there's no necessarily exponent, but because I see that x there, that I could put an imaginary 1 right there. It doesn't do anything. And then this guy doesn't have an x or an exponent, so it's 0. So once I have all of those exponent numbers, I'm looking for the highest one. Well, the highest one is this 2 right here, which means I'm going to look on this table for degrees of 2. So on the top table, we have this degree of 2 means that it's quadratic. It's that one right there. So I know that for this first example, it's going to be a quadratic. Now let's name it based on the number of terms. So each chunk is its own term. So kind of how we did those exponents. We have 3 different numbers for the exponents, which means we have 3 different terms. It's this chunk right here, this term right here, this term right here, and then this term right here. So we have 3 terms, which means it's following this rule, which is a trinomial. So my final answer is that it's a quadratic trinomial. Oh my goodness, let me spell that right. Quadratic trinomial. And that's my final answer, my full answer. Okay, now let's look at the second example. The second example is 4x to the 5th plus 2x. So once again, I'm going to start with my degrees. So this guy, we're looking for the highest exponent for degrees. The highest exponent, or the exponent on this, is 5. And then for this guy, it doesn't have an exponent, but remember, because it has an x, I can put that little imaginary 1 right there, which means that my exponent is 1. And those are the only two chunks that I see. And so my highest degree, or my highest exponent, is this 5, which means my degree in this example is 5. So I'm going to scroll back up to this table and look for the 5. Let's erase this one because that was the last example. And the 5 degree, or the 5th degree, is right here. It's considered a quintic. So let's go scroll back down and write quintic down here. All right, now let's talk about the number of terms. So there's one chunk right here and another chunk right here, which means that there are 2 terms. So if I look at my table for the number of terms, the 2 terms is a binomial. So I'm going to write binomial right here, which means my final answer is that this is considered a quintic binomial. All right, let's go to the third example. The third example is actually really simple. It only has one number and it's 5. So when we're looking for the degree, there is no x, which means that this has a degree of 0. And there's no other terms to look at. And so my degree for this whole thing is 0. So I'm going to look back up at this table, my degrees table, and look at my 0, 1. And for that 0, 1, it is right here, it's called a constant. So I know for this I'm going to have constant. And because I only have one term, there's only one number, which means I only have one term. When I look at the number of terms table, it's right here. It's only one term, which is considered a monomial. So in this case, my final answer is constant monomial. All right. Okay, one more example. For this fourth example, we have 7x to the 6th minus 9x to the 5th plus 4x to the 4th minus 2x squared minus 6. So once again, let's go through all of these chunks and look at the highest exponent. So for this first one, we're looking at that exponent, it's 6. And then the second one, the exponent, 5. Then we've got a 4 for this guy and a 2 for this guy. And then this guy doesn't have an x or an exponent, so this guy's 0. So now, out of all of those numbers, which one's the highest one? Oh, it's the 6. On all of these, the highest exponent has come in the front because these are what we consider to be in standard form. Sometimes they might not give it to you in standard form, so you want to check every single term and make sure that the highest exponent is in the front, because sometimes it might not be. So we know the highest degree in this case is 6. So now let's go back up to our tables and look for the degree of 6. So for this one, the degree of 6 is right here because we don't have an actual name for it. So when it's 6 or greater, we have to say to the nth degree. But in this case, because our degree is 6, we're going to say to the 6th degree. So I'm going to say to the 6th degree. And now let's look at the number of terms. So we've got one term right here, another one right here, another one right here, here, and here, which means we have 1, 2, 3, 4, 5 different terms. So let's scroll up and look. So 5 isn't on our list, but it is bigger than 4, which makes it this guy right here, because this one shows anything that's 4 or bigger. So 5 is bigger than 4, which means it's a polynomial. So it's going to be to the 6th degree polynomial. And there we have it. That's how we name polynomials.